Today's lesson is going to be about the domain and range of relations.
All right.
The domain in all of these relationships would be all of the possible x values. The range of these relationships would be all of the possible y values. Okay. Now, some keywords that are associated with domain would be input, independent variable. Instead of saying x coordinates, sometimes they may say use the word x values, all right, or the phrase. Now, for the range, words that are associated with range or that mean something similar to range or asking for the same values would be output, dependent variable, and y values. And y values. So it's good to know the other words that are associated with domain and range because they may use those on a standardized test and still be referring to the domain. Next, let's go ahead and take a look at how do we really identify the domain and range. So these first two examples here are dealing with ordered pairs or sets of points, okay? And they gave us a little study tip here. It says when you write a set for a domain and range, only list each number one time. If a number repeats. Okay, so if a number repeats, you only list it once. And list all numbers in order from least to greatest. So the domain would be all of our x values. So that's really the first value in each ordered pair. And we want to list them in order from least to greatest. So the least being the smallest, the one furthest to the left, is going to be +1. And since I'm done with that, I'll circle it and cross it out. Next is +2, so I'll circle it and cross it out. And now we have 3 and then 4, so circle the 3, cross it out, and then the 4, circle the 4 and cross it out. So those are the set of domain values. Now we're going to do the set of range values. Remember, range are all your y values. Okay, once again, you put them in order from least to greatest, and if a value repeats, you only write it one time. So the smallest y value is 2. Then the next is 3. And you see we have 2 3s, so I'm only going to write it one time. And then the last one is 7. All right, and that's how you do that. Let's take a look at another one. Once again, doing the domain. The domain is all of the x values, right? Or x coordinates. So x, 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 and x. And we want the one furthest to the left, the least value, right? So the least, the one that would be furthest to the left on the x-axis would be, we got +6, +2, -5, 0, and -1. Well, -5 would be furthest to the left, so that's the one I'm going to write first. Cross that out, and then I'm going to do -1. Then we're going to write 0, and then we're going to write 2, and last but not least, +6. All right. Now we want to go ahead and write out all of our range values or our y values, right? Or our output, okay? So we're going to, not circle them, but we want to label it. Y, 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 and Y. All right, now once again, we still write these in order from least to greatest. Now on the y-axis, the least would be the one all the way at the bottom, and the highest one, the largest one, would be the one all the way at the top. Okay, so our y values, our least y value here would be this -7. Then the next least would be -4. Then after -4, we would have +6. Then +8. And last but not least, +9. And now we've written out all of our range values. Okay, let's keep it moving. Now, if you have a line segment, you need to look at the ends of the line segment. So for the domain here, and it's a habit of mine, I like to label these x-axis, y-axis. Okay, anytime we have a graph and it's not already labeled, label it. All right, it says look for the domain. Well, for the domain, look at the point furthest to the left. What is the x coordinate of that point? So the point all the way to the left would be the -2. No, x is the first value and y is the second value. So the point furthest to the left and the x coordinate of that point is -2. Now it says then look at the furthest point to the right. What is the coordinate of that point? Well, the furthest point to the right is over here, and our x coordinate is that +2. It says what is the x coordinate of that point? +2. Now so we would write -2 less than or equal to x, which is less than or equal to 2, and this would be the domain for this line segment. Now if we were looking for the range, once again, now we're looking for the lowest, right, or the farthest down. It would be this +1 here, right, and then the furthest point up would be that +3. So furthest point down was +1, the furthest point up was +3. So we write the bottom number is 1 less than or equal to y, which is less than or equal to +3, and this is how we. So let's go ahead and jump into this. It says find the domain and range of this line segment. Remember, the domain is farthest left and farthest right. The range is farthest down and farthest up. Okay, so here are our 2 points. This is furthest to the left. The x value is -2, the y value is +3. So our furthest to the left would be -2 less than or equal to x, which is less than or equal to the furthest to the right. The furthest to the right, okay, is +2, and the y value, the y value is -1. We're gonna use yellow. Let's keep it color coordinated. So for the furthest to the right, it would be +2. Now let's take a look at the range, which is the furthest down. The furthest down is -1 less than or equal to y, which is less than or equal to the furthest up, or the highest point, which would be +3. Let's take a look and find the domain of a continuous piecewise line segment. Well, this is no different from one line segment. It's just a bunch of different line segments connected, and it's continuous. So we still use the same format. So going all the way to the left, remember left is going this way and right is going that way. So if I'm going all the way to the left, this is my point furthest to the left, and I want to identify the x value, which is +1, and the y value. And if we need to zoom in, we can zoom in. Okay, so once again, the furthest point to the left is, and the x value of that is +1. So I would put 1 less than or equal to x, and then I want the point furthest to the right. Well, furthest to the right is all the way at the top up here, which is this +10. So less than or equal to +10. There's our domain. Now our range is the furthest down. Once again, the furthest down is that same one that was furthest to the left. That y value is +1 less than or equal to y. And then the tallest point, the highest point, the furthest up, right? Which would be this 10,8, and that y value is 8. So less than or equal to 8. And that's how we write the domain and range for a continuous piecewise segment. If you are given a parabola, you will have to find the vertex. The vertex is the point where the parabola turns around, or what I like to say, the elbow of the parabola. Parabolas open up and down. the domain for parabolas is all numbers, and really, to be more specific, all real numbers. Okay, and the range starts at the vertex, and then it keeps going either up or keeps going either down. So this first part here says the domain is all real numbers. Well, part of the reason is, and they didn't do this on this graph, but we should, these parabolas really should have arrows on the end, which basically let us know that it keeps going on forever and forever. And I'm just labeling my X and Y axis. It's always a good math practice habit to label your X and Y axis, okay? So as I'm looking at the domain, they've already kind of told us, they've kind of helped us out that, hey, for parabolas, the domain is all real numbers. Well, so the way to represent all real numbers is to say that the domain goes from negative infinity, and let me scoot that down, from negative infinity, less than or equal to X, which is less than or equal to positive infinity. And really it's not less than, it's not equal to, it's just less than. Okay, all right, all real numbers. All right, this is how you represent all real numbers, with the infinity sign. And if you think about it, the graph, the vertex, the parabola, it's going to keep expanding more and more. It's going to keep getting wider and wider, and it's going to constantly take up the entire x-axis. So every number on the x-axis will have some y value corresponding to it. So that's why it's all real numbers. Now, the domain, the range, the lowest point, remember the lowest point is right here. That is 1. So 1 less than or equal to y, which is less than, now it keeps going up forever. Up forever would be positive infinity. All right, now let's take a look at this next graph. All right, the graph to the right. Now once again, the domain is all real numbers, because as much, if we could open this graph up more, the parabola would continue to expand and expand and expand and expand and take up the whole x-axis. So this is going to be from negative infinity to positive infinity. Okay. Now for the range, in this one, now the parabola is going down, so it doesn't have a lowest point, it has a highest point. All right, and the highest point is at positive 2. Now the lowest point, it keeps going down forever. This parabola is going to keep going down forever and ever, which is negative infinity. So because negative infinity is the lowest point, we're going to say negative infinity, all the y values are between negative infinity, y, and positive 2. All right, and there we go. That's how we take a look at these parabolas. All right, now these parabolas open left and right. So the domain now starts at the vertex, and the range is all real numbers. Okay, because the range is going to keep going on forever and forever. Put arrows on the end, and we're going to say that this is our y-axis, this is our x-axis, right? Y-axis, x-axis. And now we can go ahead and start looking at the domain and range. Well, the domain, the furthest left that this graph goes is -1. And to the right, it's going to keep going to the right forever, right? Forever and ever. So that's going to be positive infinity. Okay, now let's look at the range. The range is already told us that it's all real numbers. It's all real numbers. Everything in between negative infinity and positive infinity. Negative infinity to positive infinity. All right. Now the domain for the second one, once again, is the furthest point either to the left or to the right. Well, furthest to the left out here is negative infinity, and it goes all the way to this positive 2. So this would be negative infinity less than or equal to positive 2. In the range, they already told us that it's all real numbers. So negative infinity to positive infinity. Okay.